welcome. Operations research, game theory, games with 2 players and 0 sum. And now we are going to discuss a case of a game having no saddle point, and the point is finding value of a game without saddle point. There are many ways of finding the value of a game without saddle point. The first thing is, how can we find it? Because there is no saddle point, so there can be no optimal strategy for the gainer as well as loser. Then what to do? In such a case, the players need to use mixed strategy. That means not a single strategy every time. Different strategy every time in different proportions. So in this type of cases we need to use probabilities. But the main point is how to determine the probability. So in case of a game without saddle point, we first need to determine the probability of use of different strategies by the different players. And there are so many methods, and from which we are first going to discuss the algebraic method. In this method, we shall find out the probabilities of A1 and A2 for A and B1 and B2 for B and the value of the game. The main point is, when there is no saddle point in a game, the players need to use mixed strategies, and as we are aware that this is the game A, which is to be assumed a gainer, B to be assumed a loser, and this is row minimum, from which we have already selected Maximin value -6. This is column maximum, from which we have already determined the minimum value. This is Minimax, and we can see that Maximin and Minimax are the different values. So this game has no saddle point. Now let's proceed and suppose the probability of A using strategy A1 is X and using strategy A2 is 1 minus X. And same way, probability of B using strategy B1 is Y and that of B2 is 1 minus Y. Now, we know that if we have probability as well as payoff, we can calculate expected payoff. Since A is gainer, we shall first find everything as point of view. And let's think about as expected payoff. That means as expected gain. As expected gain is actually a conditional event. As expected can be considered on the basis of which strategy B is going to use. If B is going to use B1, if B is going to use B2. But the main thing is the expected value in both the ways should be the same. And since B is a gainer, we believe that A is the gainer, since A is the gainer, we believe that as expected payoff would be greater than or equal to the value of the gain. Okay. Now, as expected gain, if B uses strategy B1. Now, if B uses strategy B1, A's payoff are 8 and minus 6, and respective probabilities are x and 1 minus x. And as we know that expected value equals to something like x into P of x. So, the expected gain can be 8x plus minus 6 into 1 minus x, and that will be greater than or equal to value of the game, because A is the gainer of the game as we believe it. So it will be 8x plus minus 6 into 1 minus 6, and minus 6 into minus 6 x will be plus 6x. So it will be 8x minus 6 plus 6x, and ultimately it will be 8 plus 6, 14x minus 6. And if B uses B2, if B uses B2, then as expected gain will be as gain will be minus 7 and 4. So the expected gain will be minus 7x plus 4 into 1 minus x. That means minus 7x plus 4 into 1 4, 4 into minus x minus 4x, and that will be greater than or equal to value of gain, because expected gain under both the circumstances should be the same. Minus 7x minus 4x, that is minus 11x plus 4. So these are the two inequalities, because as gain can be exactly equal to the value of gain or greater than that. So there are so many possibilities. But if we believe that it is exactly equal to the value of gain, these two can be treated as equalities. If taken as equality, then it will be 14x minus 6 equals to value of gain, and minus 11x plus 4 equals to value of gain. So the ultimate value of both the left hand side of both the equations are same. So we can compare them. 14x minus 6 equals to minus 11x plus 4. That means 14x plus 11x equals to 4 plus 6. That means 25x equals to 10. Therefore, x equals to 10 by 25, that is 2 by 5, and therefore 1 minus x equals to 1 minus 2 by 5 equals to 3 by 5. Now, what is the interpretation of all these things? The meaning is, so A would play strategies A1 and A2 in the ratio of 2:3, that is 2 by 5 and 3 by 5 in a random manner. In a random manner. So the game is played so many times, and A would prefer to play strategies A1 and A2 in the ratio of 2:3 in a random manner. Now if A plays the two strategies in this ratio, what can be the expected gain of A? Rather the expected payoff or expected gain. That will be 8 into x means 2 by 5 minus 6 into 3 by 5. So that will be 16 by 5 minus 18 by 5, that is minus 2 by 5. Or if we consider that B is going to use strategy B2, then S gain will be minus 7 into 2 by 5 plus 4 into 3 by 5. That is 14 upon 5 minus 14 upon 5 plus 12 by 5 minus 2 by 5. So through both the equations, the value of the gain will be the same. So ultimately what we can conclude? Thus A will make a net loss. Why net loss? Because his expected gain is negative and A is the gainer. If his gain is negative, that means he is going to make a loss. So A will make a net loss of 2 by 5 per play. This is average. Expected means average. Expected payoff or gain means expected payoff or gain per play. So many times they are going to play the game. So in the long run, the average gain per play will be minus 2 by 5 per play in the long run. I tried to make the explanation as easy as possible. So this was A's point of view. Now if the same game is taken B's point of view, now B's point of view, we have to take utmost care because we have assumed that B is loser. This is two players zero sum game. Why zero sum game? The gain of X and loss of B will be same. The same amount will be there. If A gains 100 rupees or say 100 points, B is going to lose 100 rupees or 100 points. That's why this is called zero sum game. Now let's take the thing B's point of view. More or less it is similar. I can say that it is revision of the whole thing. So you can understand the whole thing at the end of the solution. I am aware that the lecture or the solution is going to be somewhat lengthier, but I don't mind. I want to make the concept easy for you, as easy as possible for you. More or less the steps and the thought process are same. If we consider B's expected payoff, his expected payoff will be actually expected loss. It is also dependent on the thing which strategy A is going to use. So first, if A uses strategy A1, if A uses the strategy A1, B's expected payoffs are 8 and minus 7 and respective probabilities are y and 1 minus y. So it will be 8 into y plus minus 7 into 1 minus y less than or equal to value of gain, because B is the loser. That means 8y plus minus 7 into 1 minus 7 minus 7 into minus y plus 7y. That means 8y minus 7 plus 7y, and that means 8 plus 7 15y minus 7 less than or equal to y. Similarly, what if A is going to use A2? So second will be if A uses strategy A2. If A uses strategy A2, B's payoffs are minus 6 and 4 and respective probabilities are 1 and 1 y and 1 minus y. So it will be minus 6 into y plus 4 into 1 minus y. That is minus 6y plus 4 into 1 plus 4 plus 4 into minus y minus 4y. Minus 6 plus minus 4 minus 10y plus 4. As it was in the case of A, there are two inequalities. The expected payoff of B can be equivalent to value of gain or less. So now if we believe that the expected gain or rather the expected payoff or loss of B is exactly equal to the value of gain, then these two can be treated as equalities. And value of both the equations are same, so we can compare them. 15y minus 7 equals to minus 10y plus 4. So it is 15y plus 10y equals to 4 plus 7. That is 25y equals to 11. Therefore y equals to 11 by 25. Therefore 1 minus y equals to 14 by 25. So the probability that B uses strategy B1 is 11 by 25 and the probability that B uses strategy B is 14 by 25. Now what? On the basis of these probabilities and this payoff, we can find out the expected payoff or expected loss of B also. Let's find it. But first of all, let's write the interpretation. So B should play strategies B1 and B2 in the ratio 11 is to 14, that is 11 by 25 and 14 by 25 in a random manner. And if we place these two strategies in this ratio, B's expected payoff that is his expected loss can be calculated in two ways on the basis of these two equations. It can be 15 into 11 by 25 we are going to take the original values from the table. It can be 8 into 11 by 25 minus 7 into 14 by 25. That will be 88 by 25 minus 98 by 25. So it comes to minus 10 by 25. That is minus 2 by 5. Or it can be calculated with the help of A2 also. If A uses strategy A2, it will be minus 6 into 11 by 25 plus 4 into 14 by 25. Minus 66 upon 25 plus 56 upon 25. So it is minus 10 by 25, that is minus 2 by 5. Now we know that we have taken B as the loser. His loss is negative. That means B is going to make a gain or net gain. Thus, B will make a net gain. Negative loss means gain. Net gain of 2 by 5 in the long run. And thus, as a common conclusion, A and B should both use, don't forget to write all these, as and when you refer to the case, you can understand the whole thing on the basis of this writing, and in examination also you need to write all these things. Use mixed strategies. Mixed strategies in the above manner, and the most important thing, the value of game will be minus 2 by 5. This is the common conclusion of the entire case. We solved the whole case A's point of view as well as B's point of view, and the common expected payoff is the value of game. I know this is somewhat lengthier way, but this is one of the important techniques of solving a game without unique saddle point. I ought to explain this to you. I tried to make this as easy as possible, but I cannot say reduce the explanations as well as steps from this now, as it will be the injustice to the method, to the solution, to the teaching. In the next lectures we are going to discuss other methods of finding the value of a game without saddle point. A small summary. In this method, first of all, the probabilities are determined. Probabilities of what? Probabilities of using different strategies by the players are determined. And then on the basis of these probabilities, we can calculate the expected payoff of both the players as well as the value of game. That's it. Thank you very much.